did we get? Good morning. It's time to get started. So we did get some volunteers on the mail list who were willing to take notes. I greatly appreciate that, but we did not yet get a JavaScribe. Looking for a volunteer, please.
Actually, the volunteers were kind of forced to volunteer, but I appreciate Danny and Bob to let you take minutes. Thanks.
Can we at least have someone who will go into the Jabber room and channel remote participants when we get to that part of the session? We can wait. Thank you, Robert. All right.
Okay, so let's get started. So, well, first the usual things, IPR and not well. You should be aware already by Friday of this, but just in case. We already got the blue sheets are around, so please send the blue sheets. Note taker, again, thanks Danny, thanks Bob, and JavaScribe, thanks Robert. This is our agenda. It's quite focused, the agenda for today's session. So we have three presentations, one on a working group document by Alex, and two additional ones on charter items, but on documents that are in individual submissions. So this is the time we should have time for presenting and having some discussion. And then before we start, just a very brief update of the status. Since Seoul, we got a document adopted, the document, the basic milestone of the specification of IPv6 over OCB. That will be first presented, and we have still two main milestones that we should try to meet, that are the other two main documents that we need to find out, well, to adopt a working group document, and we'll have some discussion later today. And that's pretty much it. So, Alex, whenever you're ready.
Do we have a pink box?
Yeah, there.
Yeah.
Sorry?
Yes.
Hello, my name is Alexandru Petrescu. I work at CEA, and I will take 25 minutes to present the advancement of the IPv6 over 802.11 OCB document. I'm the speaker, but these are my co-authors, and this is the draft name. You can find it on the internet. The version number is 02. I will first present a few issues that have been solved more or less, but well, I'm looking for a confirmation, or if somebody does not like the way they have been solved, then now it is the time to say it. But otherwise, I consider it solved. And then towards the end of the presentation, the other issues that should be no problem. They have been solved, and they have been confirmed on the email lists. So let me go one by one. There are about 19 slides. Yeah, okay, so once again, there's a few new figures. One figure that you see here that pictures a Ethernet adaptation layer between the IPv6 layer and the MAC layer. Okay, this is a new figure that has been added. A second figure is an illustration of approximately the same interface between IP and the MAC, but uses more IEEE terminology. Like, for example, it uses the EPD term, stands for Ethernet Packet Discriminator, if I'm not wrong. And yeah, this is the view that is more or less agreed as a view of the interface at IEEE. The interface is called this LLC SAP, Service Access Point. So we have a boundary here and services below. These are two new figures that we added to the draft. Next, I'll go to the next slide. Well, with respect to these two interfaces, I mean, there is only one interface between IPv6 and the MAC. Okay, this interface is called differently. Some call it Ethernet adaptation layer, others call it SAP, Service Access Point. But also there is a proposal to actually call it to be the SNAP. SNAP is a name that is described in a RFC 1042, and the proposal is to add the following text. In addition to the description of interface between IP and MAC using Ethernet adaptation layer and Ethernet protocol discrimination, it is worth mentioning that SNAP is used to carry the IPv6 ether type. So if there is no opposition, I'm going to add this text to the draft. Okay. I will go to the next slide. Earlier we had a figure that is this one. Okay, it pictures a 802.11 data header, an LLC header, an IPv6 header, and a payload. And it also pictures the Ethernet adaptation layer that realizes conversion between these headers and the Ethernet 2 header. A person sent me a comment that the 802.11 packet also has a trailer. It's called frame check sequence. So I will add this trailer to the figure. Okay. If there is no opposition, I will add this trailer. The contents of the trailer are not significant to the Ethernet 2 header, but they are seen in the packet captures. Okay. There is always a trailer there and should also be in the figure. If there is no opposition, I will also add this trailer. Now, one of the comments was that we have an empty section, the section of address mapping unicast. And it is true that this section at this time is empty. Why it is empty? The reason why it is empty is that it should be, the contents of this section should be the same as section 6 address mapping unicast described in RFC 2464. I remind, RFC 2464 is called IPv6 over Ethernet. So since this RFC 2464 is very much a base of our document, we don't know at this time what is the status of document RFC of draft 2464 bis. And that is going to be updated, okay? And we don't know exactly what is the status right now. The content of that section in RFC 2464 is pictured here. And if we read it as it is now, we cannot copy paste like this because it has a number of issues. For example, the reference here called disk is actually maybe RFC 4861. And also there is a problem in this text here of the Ethernet address. The formulation seems to be, well, not clear, at least to me. This formulation here says that the MAC address should be put here in this encoding, but we have this direction at IETF where less and less we rely on these MAC addresses because of privacy reasons. So it's hard to copy-paste entirely this section. So at this time, I think I don't know what to write in this section. Section 6, address mapping unicast. I think we depend a little bit on the advancement of 2464 bis. Or, I don't know.
Bob Hinded, I'm the editor of 2460 bis, and it's not, at the moment it's not moving quickly because of the impasse we've had on the update to the addressing architecture. But at least I believe the multicast section is probably stable, but on the other hand, I don't know how much review the current draft has had, and so it's, this is a work in progress. So that's the current status, but yeah, and so I would also have to look at the issues you're raising on this slide. But
okay,
yes, send me a note about that. I will at least take a look.
Okay, I will send you a note about this. And
Bob Moskowitz, HG Consulting. Since IEEE 1609 is already addressing the privacy issue of the MAC address, I would venture to say that the privacy issue of the IP6 address formulation can thus inherit the privacy of the MAC address. And we don't have to then do additional privacy concerns in the IPv6 address formulation.
So you are actually suggesting that we look closer at this 1609 document that tells how to form IPv6 addresses?
Well, how they form the MAC address, the fact the MAC address is, they take privacy for the MAC address itself that they have in there, and then they formulate the IPv6 address based on their privacy enhanced, if you will, MAC address.
Okay, yes, so that is a good suggestion. We can have a look at that document to understand the privacy of MAC addresses. But this is just one. Here I'm just showing one little aspect of this entire privacy discussion. I mean, is 1609 giving a method to encode the MAC address into a TLLIO, which is this format?
No, it's you take what they have and put that into there. You take your section there on Ethernet address. You reference 1609 formulation of the Ethernet address, and then you can talk about then the rest of it, building up from that.
Okay, that could be a good source. We can do that, but then we also have to do it in the same manner that RFC 2464 bis does it.
Yes,
and
you got. I guess we got to kind of munge them together.
Yeah, the two. Yeah. Okay.
I mean, Eric Nordmark. So I think there's something that's easy here, which is just if you copy that sentence, you remove the second part of it, because we don't only we form interface identifiers in multiple ways, and forming them using a MAC address is only one of the ways. So this text is a bit old, right?
Yeah.
So if you just strike that second part, now you have something that describes what this is for, which is, you're carrying the layer 2 address. Whether or not that's used to form any interface ID is completely orthogonal, right? This was just some text that was believed to be explanatory when it was written, but is no longer very helpful.
Yes, yes.
So that, I think that's the easy part, right? The
Yeah.
harder one is what Bob brought up, saying, okay, if we have privacy improvements on the MAC addresses, well, does that mean that we should also form interface IDs on those so that we switch them at the same time, right? Because we need to do the switching to provide unlinkability, we need to switch things up and down the stack all at the same time, right? And that's one way of doing that. That's might not be in scope for this working group. I think it's something that we should figure out, right? And one can draw a sketch of that, saying, yeah, you could do what Bob proposed, or you could say, well, if I have some interface ID not formed from the MAC address, I still need to switch it when I switch the MAC address. Otherwise, I have linkability between them. So, but yes. I don't think you have to go into that here.
No, yeah, no. Okay, so but okay.
Suresh Krishnan.
Okay.
So I'm kind of lost in this, because I think what everybody else is talking about is not about address mapping to unicast. They're talking about another section, which is how Slack addresses are formed, right? Because this is this section needs to talk about how the other direction works, how you translate from the IP address into the MAC address, right? Because IPv6 over foo has two things. One of them is how do you form the IID for Slack?
Yes.
Which is where all these discussions are supposed to be, not in this section. So I'm really lost here, right?
Okay. Yeah. So it is true that this actually is a option necessary to neighbor discovery.
Correct.
To perform resolution.
You put in whatever your address is, right? Whatever your IID is, or whatever your hardware address is on going out of there.
Yes.
Right.
And this goes on the same.
If it's random, it's random. You put it if you had a randomized MAC address, you put that in there. If you don't have a randomized MAC address, you put it in there, right?
Okay.
And I don't see the problem in this section. This problem exists, but it's in a different place, not in address mapping unicast. It should be in the Slack section. Because the IPv6 over foo has a Slack section, and that's where this should all be discussed.
Yeah.
Okay. So, and the text, I agree with Eric that the text at the end is kind of not needed, but it's still correct because it says it may be different anyway. So I think it's correct, but I think it's fine with fine tuning that one. Okay. So it says it may be different from the one used to derive the interface identifier that fits whatever, it fits privacy addresses, it fits stable privacy, it fits whatever, CGA, whatever, right? So that's still okay. Right. So the text is correct, but it's probably not necessary.
So you think this text here in its entirety is correct?
Yes, I think it's correct, yeah. And it says it may be different from the built-in address used to derive the interface identifier. The point is, yes, it can be different.
So how can the 48-bit Ethernet IEEE 802 address be different from the built-in address?
No, used to derive the interface ID, because you can derive the interface ID in a different way. Correct. That's what I'm saying. So that's why I'm saying it is correct, but not necessary. It's saying it may be different.
Oh, but it's implied. The particular wording, which was true at the time, is implying that interface identifiers are only derived from MAC addresses, and that's no longer true, right? Because it doesn't say if the MAC address is used to derive the interface identifier. It assumes that it always is. So that's why I say just get rid of that part. Because we have more flexibility. It could be, in which case it could be different, or it could not be, in which case it's irrelevant.
Right, Eric. So, Suresh again. So that's why I'm saying, there's another section that needs to get fixed in. That's the Slack section. And if you don't fix it here, there's no point talking about this here. Okay? Because there's you need to explain how the IIDs are formed in a different section, which is not this section.
It is
I want that to be fixed over there. All this privacy stuff to be fixed in that section.
And I think that is okay. I think that is fixed in that other section. Okay.
Yeah, Bob, I'm just confirming what Suresh said. I mean, I agree that extra sentence is not relevant to this section. It's just making sort of a note. The other section earlier in the document, section 4, is about how this works in regard to stateless auto configuration. So this is not that sentence is not really relevant and probably less relevant now than it used to be.
Okay, so that goes in the direction of removing that last section here. And okay, I will remove that for the next revision of the draft. And yes. So that's about this issue. I think we have a resolution here. I will copy paste entirely this text and remove the last paragraph, the last phrase here in the next revision. I'll go now to the next slide. This is more of a, well, it's a little bit higher level, more about policy. The discussion, let me give a little bit of context. In the initial versions of this draft, we were specifying precisely what are the places, what are the standards development organizations that prohibit the use of IPv6 on 802.11 OCB certain channels. And in the initial versions, these places were, for example, FCC in America, but also IEEE 1609. And the discussion on the list illustrated that FCC, maybe we should not talk about it here, or maybe FCC is not really prohibiting the use of IPv6 on these channels, and maybe there was some misunderstanding in interpreting the intention of FCC. So we removed the statement saying that FCC is prohibiting the IPv6 use on 802.11 OCB. What is still left is this 1609. Okay. People said that 1609 still prohibits the use of IPv6 on certain 802.11 OCB. And this is the text here. Prohibition of IPv6 on some channels relevant for the PHY of IEEE OCB, as opposed to IPv6 not being prohibited on any channel. At the time of this writing, this prohibition is explicit in IEEE 1609 documents. This is the current text that we have and we keep. In addition to this, a suggestion was made that ETSI may also prohibit this IPv6 on certain 802.11 OCB channels. And I don't know what to do with this suggestion. Maybe add also that ETSI also prohibits it, or not talk about ETSI at all, or yeah, I don't know what to do. At this time, I prefer to keep the current text as it is now. Yeah.
Russ Housley, my suggestion is that we say that some channels are reserved for safety messages, and that IPv6 frames, packets, whatever word you want to use, shall not be used on those channels, and leave it at that.
Okay, noted.
Yeah, Michel Vetarval from FE Consulting. I'm at ETSI. I do agree with Aldous that this is related to some channels, some control channels where you have the safety messages. It's not related to all the channels, because usually we separate the layers, and you can use any access layer with IPv6, except on some specific channels where you have to use the dedicated protocols.
Okay.
So prohibited at ETSI, not formally, but you should really on the control channel, no. You should not use it. So I fully agree with what has been said before.
Okay, so formulation like IPv6 is allowed on some channels, just that, not specifying whether ETSI or IEEE or...
And should not be used in the safety control channels.
Yeah, but then it comes to the definition of what is the safety control channel, and this is different in America as in Europe.
Yeah, but you have the reference to the standards in your draft.
Yes. Okay.
Okay.
But then the prohibition is hard to implement. But okay, I can write that. I can come with a new text here based on our discussion.
Hi, Bob Moskowitz. I have a slightly different suggestion on this section, because you just talked about US and Europe. What about Japan, Korea, China? I think rather each there's going to be documents which are going to talk about channel utilization, and they tend to be national and tend to be sometimes captured in IEEE documents. And maybe the best thing to do is simply reference national channel utilization documents should be reviewed or referred to on use of IPv6 on any channel. Really toss it over the wall and say that we don't know where it's going to go the next 2-5 years. Just, and tell the reader, look what your country is regulating.
Okay. National channels. Okay.
Yeah. I think Bob Hiley may actually have real experience on this and maybe can add some words on it because he's really had to deal with it. Bob? No, he won't.
Okay, so if this seems to be a good conclusion here, a new text that will say that IPv6 is to be used on certain channels and there is prohibition of other channels of the use of IPv6. And for more information, please look at the national recommendations of channel use of respective country. Okay, I go next. Well, there was a discussion on the use of the roadside unit term, and I concluded this discussion with using RSU. There were some proposals. Okay, RSU stands for roadside unit. A roadside unit is a IP router equipped with or connected to at least one interface that is 802.11, and that is an interface that operates in the OCB mode, outside of the context of a BSSID. There were other proposals for this RSU term. Well, I emitted this proposal of RSR, roadside router, but there was some opposition. Then there was a discussion whether RSR is a component of a RSU or vice versa, because we saw illustrations of RSU in some deployments in which the RSU is a router, is a bridge, and is not called a router because next to it sits another router called backhaul router. But so it was really, we could not end this discussion of RSR or RSU. And there is a suggestion from ISO, very important, ISO TC204, to call it R-ITS-S, roadside ITS station, which is an ISO TC204 term. Roadside ITS with an ITS access router. Roadside ITS-S with an ITS access router. Well, on my side, I found this term relatively long. Looks sophisticated, has a good level of sophistication into it, but it's relatively long. And in my own discussions with many people, I hear a lot this RSU term. So this is why I continue going with RSU.
Carlos Bernardo. So one question, why can we just use the term router? And then maybe in the terminology section refer that in ETSI terminology, this router with this interface is referred to as RSU, but just use router. I mean, we are just doing IP over OCB, and this is a router, right?
Okay.
I don't know. I mean, maybe we are, if we start using terms that are used differently, that may lead to confusion, and it's just a router.
Yes. To give a little bit more background context here, this RSU term is used mainly in the handover discussions when performing handovers between RSUs. But yeah, we could just say router, but it's more like an access router or, okay, router, and say that a router could be RSU or RITSS or, okay, noted.
Andrew Allen, BlackBerry. I think I prefer the router as well because roadside unit is kind of generic and there may be other roadside units and that could cause confusion later. Also, do you really want to, I know this draft is about 802.11 OCB, but do we want to tie the definition of the roadside router to be that? Then that's just restricted just for this document, whereas there may be other roadside routers using other technologies. So. maybe you could say for the purposes of this document, it needs to support the 802.11 interface in OCB mode, maybe. But maybe keep the term generic if there are other things defined later with other protocols, then the same definition would apply.
Okay. Yeah.
This is Paul Zhang. So as you know, many academia, the society, the parallelly using the roadside unit. So I think the RCU roadside unit will be synchronized with the academia, and also in my experience in the last 10 years, roadside unit will be used in the future. So I prefer to use a roadside unit.
Please say that again.
But we can clarify this is the IP router in the draft. Yeah.
This is IP router. Yeah, we can say that. Yes, we will clarify this. Yeah.
Okay, I had raised a concern here because when you say roadside unit is an IP router, a roadside unit actually may have other functions, like upper layers and things like that. That's why I raised the concern about this usage, just this definition of a roadside unit as an IP router. So I like the proposal to have it as a router.
Router. Okay.
Just a router, because RSU is maybe more than just a router.
Okay, it's going to be router. It's okay.
Hello, my name is Georg Meyer. I'm with 3GPP.
Router, the device that makes routes.
I'm with 3GPP. I'm looking in our specifications. The roadside unit is defined as well for V2X, and it's a much more generic term, stationary infrastructure entity supporting V2X applications, etc. So I think in order to not create massive confusion, it would be good to have here that you say this definition only applies for this document. Because there are several definitions out there existing already, and if people look at this and look at this, like roadside unit is then used in your document, in the 3G documents, I know you're not seeing a strong connection between them, but readers might try to make such connections, so it might be good to have it a bit more encapsulated.
Yes, please say again your name.
Georg Meyer.
From?
I'm the liaison person between IETF 3GPP from 3GPP side, and I'm working with Huawei.
Okay, noted. And we will take this to stress that this is a definition for this document, a router in
right.
This document.
That is all. I mean, however you define it, I'm more or less happy.
Okay.
But just to be clear that there are other definitions around.
Okay.
Thank you.
Good. This concludes this issue, and now we will go to other issues that I will go quickly through them, although they are maybe as important as earlier. Okay, there was discussion about the multi-channel issues. One comment is that this draft does not really deal with multi-channel, and it is true, and it was not the intention of it to deal with multi-channel issue. And here are the comments that have been expressed, but my suggestion would be to write another document, a separate document that deals with multi-channel issues for IPv6 on 802.11 OCB, like switching between channels or simultaneous use of channels or things like that. Why this suggestion? Because all other IPv6 over foo documents don't describe multi-channel issue, and I don't know how to describe that. I think it can go into a very long description with new mechanisms that may have their own IPR stuff and so on. So at this time, I suggest to write another document. So anybody intent and anybody working on multi-channel issues in 802.11p, please write another document. This is very good to progress, and there will be users of this multi-channel document. Handovers, the same situation. we had an entire section describing how IPv6 handovers happen in 802.11 OCB. The problem with OCB is that it has nothing facilitating the handovers, and we would need to use something from OCB in order to perform handovers. But there are at least 4 options, 4 possibilities to use on 802.11 OCB to realize handovers. And they have been discussed, they have been written in earlier versions of the draft, but they are incompatible with one another. So at this time, I suggest to remove the entire section handovers between OCB links. Just keep these 2 small paragraphs in which we say there are currently no specifications for handover between OCB links, since these are currently specified as LLC1 links. That means connectionless. Any handovers must be performed above the data link layer. This is a new paragraph to keep inside, and then write another document about how handovers would happen in OCB links. And once again, this is going to be necessary. A car moving from one router to another router, from one roadside unit to another roadside unit, will need to perform IP handovers. How will that happen? We need to see, okay? So please write another document.
So Alex, that IP security layer thing in parentheses, are you talking about IPsec?
Okay. Let me see. In IP what?
Are you talking about IPsec, encryption at layer 3? What
yes.
does that mean is what I'm asking.
Which, because I was on handover.
Yes, you have
okay.
your new text.
Yeah.
The last
Okay.
sentence of the first paragraph.
It's the first paragraph is a conflated. The first paragraph talks both handovers and IP security. Okay. Now, at this time, I'm just talking about handovers. IPsec is another thing, and IPsec, yes, is network layer security.
Okay, so at least put a reference there. So, because I couldn't from the sentence figure out what you meant.
Okay, reference to IPsec, RFC 2000 something. Okay, I will put a reference there for IPsec. And there was discussion about T-class. T-class is a information element in 802.11 information basis, and there may be a need to map 802.11 T-class elements into IPv6 traffic class fields. Once again, the discussion could be very long. Another document could be relevant. So if anybody is expert on T-class, please write a document about T-class and IPv6. And if it advances, then maybe we can include it here or see later. The certificates. Well, we earlier had a paragraph that said each IPv6 over 802.11 OCB packet must contain a certificate. Well, security in general is very good, but also can make things too big. If each IPv6 packet contains a certificate, it may have some problems. So I remove this text, and I suggest to write another document.
So restriction, not specifically regarding this, like I'm really concerned with this, write another document, right? Like, so the working group is not chartered to do other documents, okay? So either you can say this is out of scope and try to get consensus on it, right? Okay. Or not. Like, you cannot say, like, oh, somebody write another document because it sets expectation on other people that their stuff will go forward, yes, which is not clear. So this is like a generic comment for the last 3 things. So just making sure it's clear to everybody in the room that if these kind of things need to happen, either they need to be in this document or, like, you know, after a recharter. No, it's not, we're not chartered to do, like, you know, point solutions for pieces of these. Okay?
No.
Okay, cool, thanks.
Bob Moskowitz, yeah, this needs to be taken out. The whole certificate in the 1609 safety messages, it's necessary because those are broadcasts. Those are not to any necessary roadside equipment. Now, if you look at the basic model that they're dealing with there, you understand why they did what they did. Here, we have a totally different operational model, and it doesn't even apply in our operational model. So, yeah, get it out.
Okay. Okay. Next, well, this non-IP communications, we had an entire section describing non-IP communications. The initial proposal was this section D2, and we were discussing about may not or cannot use the CAM or DNM or these ETSI messages. And finally, a second proposal was made to remove the appendix section called non-IP communications, and I find it logical because this draft is IP over. So it doesn't make much sense to describe here too much detail about non-IP communications. Okay, non-IP. Not here, so I removed it.
Suresh Krishnan, so like the may not is not even a 2119 keyword, and I don't think it means whatever you think it means, but I don't like that one, but I'm fine with whatever else.
Okay, good. Privacy, we have a privacy paragraph. There is this old text here, and there is an improvement to refer to functions addressed in IEEE 1609 clause 551 and IEEE 1609.4 clause 67. And I find this, I did not look at these clauses, but I think it's just more detail about the reference, and I think it's innocent, and I think it should be added to this paragraph. Yeah.
If you do that, you must put the year of that standard. You must say 1609 whatever year it is, because the next version of 1609, the different year, may be a different clause number. The way that IEEE does their documents, you must put the year in for the reference standard.
Noted. Okay. Okay. Good. Good. And a new improvement on privacy text. This is a new, yeah.
Hi, it's George Garjanis from Huawei. I have a question on the previous slide where we're talking about the CAM and the message. Yes. Why are you actually mentioning here that CAM and maybe also DEM do not need to be used? I mean, you don't know. It might be needed.
Yes. Okay. So,
in answer to that question, at least the U.S. government agencies involved, I can't speak for ETSI. The position is that safety messages cannot have any additional processing overhead, time criticality, the rest of it. They are basically directly, that WAVE was designed to be as little as possible for support of safety messages, that you must not put anything else in because these are safety related. And that's at least, I can at least speak to my conversations with US DOT people on this subject. So this is that text was appropriate, but doesn't belong in this document.
Okay, but then if that is the case, then motivation text should be added, or you remove the text. I don't know.
Okay. Since I'm very late in time, motivation. If you please send motivation text on the email list, and we can look at it. Bob told me. Okay, I will listen to the replay of this and then write it down. Okay.
I was happy that you removed this section because I think we have solved it already before when we have said to refer to the national standards.
Yeah.
So there would be nothing more here than what is in the national standards, because the national standards decide.
Yes. We talk about national standards when we talked about the channel use. The national standards tell which channel use.
No, before when we were using prohibiting IPv6 on some channels.
The prohibition, yeah, the channel.
So it's about the same.
It's about the same.
The same issue.
Okay.
So if you say it is decided by national standards, you don't need any section here.
Okay. Yes. It is the same, and we don't need any section here. Okay. Up. Privacy 2 of 2. This is a new old paragraph here and the new paragraph below, and actually the improvement here has been suggested by the person in the room, and the new thing that we added here towards the end of the paragraph is the use of the word tracking. We have to protect against tracking vehicles, and this protection may involve avoid tracking based on. Sorry.
Go to the microphone.
Four. Yeah. Okay, typo. Yes, there is a risk of being tracked. This is the main thing that we didn't have before. So we added here this tracking. Okay, not only privacy, but being tracked. And we refer to a later section called design consideration section. Is this okay, Michel? Yes. Is this okay with you? Okay. And I hope everybody is okay. If there is not okay. Okay, and finally, new figures. We have debated a little bit these figures already, and we will go with this. In this figure, we represent on the left column traditional IEEE 802.11 message exchanges, like beacons, like probe request response, like association request response and data. And we see a distinction between STA role, station role, and AP, access point role, whereas in 802.11 OCB mode, we only have data bidirectional message exchanges between STA 1 and STA 2. And this is a new figure that we added and that we agreed on, at least on the list. Okay.
So this is Russ Housley. I have two concerns with this. The figure A shows the data only flowing in one direction.
Yes.
So that doesn't seem right. And the other implication from this picture is that OCB supports a lot more data, right? When actually we think the associations are going to be much shorter and quicker as you're traveling down the road talking to devices. So I don't know, somehow I don't know how to show that, but the implication, the visual implication doesn't feel right.
Okay, so what you're saying that the visual shows too much data with compared to it.
Correct.
Okay.
So maybe if both of them that you just showed a back and forth data and back and forth data.
Noted. So if I remove some of the arrows.
Thank you. Yeah. I want to observe that we have slipped into the not identifying yourself when you go to the mic, so please do that.
Bob Moskowitz. I mean, I have basic grief with these figures all together. There's a real 802.11 person sitting here who's sitting very quietly, but 802.11 doesn't even really define access point. It's just a station that has certain characteristics, and really the right there is still stay in 802.11 language, except that the stay that does. And if you look at 802.11 in ad hoc mode, you see all those messages even in ad hoc mode between two stations. So we can get really twisted in knots here. And is this really adding any value? I mean, somebody who's
illustrate-
doing this has better have some understanding experience with 802.11 to begin with.
Okay. I think any illustration adds value to the quick reader. The slow reader may not need the illustration, and text would be enough. But of course, there is an option of removing these illustrations altogether.
Then you may say traditional 802.11 in ESS mode.
Okay. 802.11 in ESS.
Do I have that right, Dorothy?
Yeah.
ESS stands for Extended Service. Okay. Okay. 802.11 in ESS mode here. Okay.
Dorothy Stanley, Hewlett Packard Enterprise. Not wanting to, there are a number of ways you could solve this problem. I think what it looks to me like what you're intending to describe in figure A is infrastructure mode behavior.
Yes.
Or the traditional station access point, what everybody is experiencing in this room who's connected to the 802.11 Wi-Fi system. That's what you're trying to describe. Thus you have the AP in the station. So I would call it infrastructure mode.
Okay.
We can decide if that's the right mode. But in B, you have OCB mode, right? So I think we should have a
Infrastructure mode.
equivalent term there. Yeah, infrastructure
Okay.
mode is
Okay, noted. Makes
what
sense.
I would recommend.
Okay, we will take that note from expert, and we will reduce here the number of messages, add here infrastructure mode, and this would be it for more clarification, for a better figure. And I think a very good comment. We have this figure that is there copied from RFC 2464, and it's there since a very long time. And it has this bit string somewhere in the middle of it. Okay, 16 bits here. Okay, and nobody explains what is this 16 bits. Many people know it's 86DD, but we felt like it's important to add this description. The Ethernet two fields are the following: the destination Ethernet address, the source Ethernet address, and that this binary string means Ether type value 86DD. And it's a small improvement, but I think it is necessary. And we have put it there. Discussion about beacons. What does beacon mean? And the agreement that 802.11 OCB does not use IEEE beacons. This is what we put in the text, even though there may be some messages that are sent in a way that beacons are sent, that is periodic messages, like heartbeats. But the IEEE beacons are not used in 802.11 OCB. And this was the agreement on the list, and we will put it that way. Multiple interfaces. Yeah, let me see how many slides I still have. This is the last one. Okay, yeah.
Dorothy Stanley, HPE. So yeah, on this one, the term IEEE beacons, I think, is not terribly well formed. There really aren't IEEE beacons. There are IEEE 802.11 beacon frames or beacons. So you might want to qualify that with 802.11.
Yeah. Let me read it's difficult to read from this position. This will require packets sent by the radio in front. Yes. This is happening again in the appendixes, okay, Appendix D. So it's not something it's something more for your reference or for your understanding. There were people who have implemented the use of multiple OCB interfaces in vehicles. And what they say is that the initial text here describes that multiple interfaces may be needed in case a vehicle has one interface towards the forward of the vehicle and another interface towards the rear of the vehicle in order to form platoons. It just says that. Now, the person having implemented the use of multiple interfaces is also saying that when in this context the protocol mobile IPv6 is used, then the RFC 5648 called MCOA, multiple care of addresses, should also be used, or is relevant, at least he said it is relevant for mobile routers with multiple interfaces. And we added this paragraph saying that if mobile IPv6 with NEMO extensions is used, then multiple care of addresses is used, is relevant at least. Yeah.
Suresh Krishnan, so I'm not sure what value this adds, right? This is like an optional extension on top of whatever this is, right?
Yeah.
So this can be done on top of any IPv6 set of links. So I'm not sure what's relevant here. And if you go down this path, like next thing you need to do 6089, which is like the flow bindings for MCOA as well. So I don't like going down the slope because I think it's really orthogonal to this, because MCOA can be used with not vehicle stuff and vehicle doesn't have to be used with MCOA. So I would really like the previous text. Keep the previous text.
Keep the previous text.
Yeah, thanks.
Noted. Keep the previous text. So I don't know if the person is in the room. Yes. Okay. So we will keep the previous text. And this concludes the presentation.
Hi. I'm just waiting to finish. You managed to read this. I think you mentioned some of the things. Of course, I have not read 1609. But regarding handover and other, the interfaces on the 11, I'm curious that whether you or the people are aware of 11U work and also IEEE 802.21 work, where a lot of handover and MAC convergence layers were defined there, and that can, bridge the gap. So I don't know, you mentioned about handover is a separate draft, but I would encourage to look at those documents which are available, freely, and then make some determination.
Yes, noted. 802.21 was part of the handover discussion. So if handover work happens, then should...
So 11U, through 11U actually it was defined in new. Yeah, it was now 2015, right? It's March in 2015, right, Dorothy? 11U is now merged within 802.11 2015, right? 16 version. So there is a generic MAC convergence sublayer has been defined there, which is called MAC state convergence functions, through which the higher layer, even IPv6 can interact with the management plane. So that is, I think, what to investigate. Then you do not need to define a new adaptation layer, which I have seen earlier in your presentation. So this is something I think worth investigating, that whether you can reuse that, not inventing again.
Okay. For clarification, the adaptation layer is between 802.11 and Ethernet, not between 802.11, A, B, or G, or U, or it's between 802.11 and Ethernet. And there is no common MAC between those two at this time.
Okay. Okay. Yeah. Okay. I as I mentioned, I need to read 1609 a little bit more to understand.
Okay.
Also.
Okay, the current milestones for in our charter say that we're going to be done with this document in May. So we need to pick up the pace if we're going to even come close. What I'd like to do is the chairs have already asked Alex to drive the discussion on the list issue by issue, raise an issue, get closure, raise an issue, get closures. So we're going to be doing that. And the hopes is that we'll be ready for working group last call before Prague. Okay?
So it will be good if we get some reviews of the whole document. So people please try to review it and provide comments. So next one. By the way, where are the blue sheets? If somebody has not signed, please.
Hello, everyone. My name is Jaeum Poljang from Sungkyunkwan University in South Korea. The co-authors are Sandra, Nabil, and Jeremy, and Michelle. Thank you for their help. So this draft talk about the survey on IP-based vehicular networking for IETF. Okay, next slide.
Push the button. This one.
Okay. So the updates from the previous the draft. So there is two updates. First of all, so I added a new IP address auto configuration subsection from the Michelle's paper. So it talks about the cross-layer identities management in IETF stations, which means if a vehicle as IETF station using multiple wireless access networks, the identities such as MAC addresses should be identified for a single vehicle. And also the second update is we added standards the body's activity for vehicular networking. So objective of this paper provides general problem areas for the IP waves. So that in order to that, we surveyed the activities, academia, standard developing organizations, and industry for IP-based vehicular networking. The assumptions are we consider L2.11p is the IEEE, the ITS MAC protocol, right? And also we consider IP version 6, and also load side unit is required for the vehicle to infrastructure communication. Also, traffic control center is a central node having the vehicle information such as vehicle trajectories and also some driver information as vehicular cloud. So this shows the structure of this draft. The first IP address auto configuration, this time enhanced with the research paper, cross-layer identities management for IT stations. And the last one is standard activities for vehicular networks. Okay. So cross-layer identities I mentioned, if multiple access networks are used for the IT station, such as a vehicle or RSU, so especially vehicle case should be identified correctly with the multiple identities or identifiers, such as the MAC addresses. Also, the edge geo networking case, they're using pseudonym for the privacy for the vehicle. So periodically or non-periodically, the MAC addresses is changing. Correspondingly, the IP version 6 address should be changed. Second part is standard activities for the vehicular networking. So we have three activities. The first one is IEEE. The second one is the ETC. And third one is ISO. The first, the IEEE case, they standardized the wave structure. So we will say 1609 is a suite of standards of wave developed by the IEEE. So for V2V, V2I communications. So it has one of the standards, the 16090 is the architecture document. Okay, so it has two data plane protocols. The first one is the non-safety, such as the IP6 version 6. The safety case, the wave sort message protocol stack is used. This figure shows the protocol stacks. So here, the wave 5 to the 11P, also 11P consider also MAC address. Also, multiple channel or channel coordination is specified 16094. Also, upper logical link layer is the L to the 2. And then I mentioned that the first one is the non-safety stack, the IP version 6, over that, the TCP over UDP, non-safety application. On right-hand side, web sort message for the safety. Okay, Bob.
Bob Moskowitz, just for technical correction, 82.2 was sundowned. It no longer exists. So you're going to have some other label there, or just leave it LLC. But there's no longer an 82.2.
Okay. Okay, so we remove LLC? Okay, thank you. Oh, this one, this is a takeout? Okay, takeout, okay. So LLC exists, right? Okay, thank you. Okay, so another, the wave, the standard is 1607, defines networking services consisting of the IP and the transport layer. Okay, so it provides addressing and routing services, so safety and navigation, etc., or the adaptive cruise control applications. Also consider multiple the lower layers. Also, it provides a requirement for IP version 6 configuration, such as addressing setting. So it providing the separate auto configuration the mechanism. So it providing the gateway address and the prefix information without using neighbor discovery. So they try to minimize delay. So without using neighbor discovery. So this wave routing advertisement, this is advertised by this protocol. Okay, so they don't use the neighbor discovery. Okay, and next one is Edge, European standard. So they basically based on the geo networking. So geo networking is defined at this number. Okay, and also IP version 6 or over geo networking is specified another document. So 302.636.6-1. Okay, so they are using adaptation layer, sub-layer protocol. It is called GN6ASL, geo networking to IP version 6 adaptation sub-layer. So this adaptation sub-layer enables the following things: the V2X communications, also global IP version 6 address acquisition, or the operating as a mobile router for the network mobility, such as NEMO. This figure shows a protocol stack. So this is a geo networking protocol stack case. It using the the transport layer protocol, basic transport protocol, and also if we are using the TCP/IP case, so GN6ASL, the adaptation layer is used. Okay. So the ITS case, IP version 6 over geo networking protocol, okay, introduces 3 types of virtual link, considering the symmetry reachability using stable, geographically scoped boundaries, and also it supports the neighbor discovery, including the Slack. Also, a dynamic definition of a broadcast domain. Remember, the beaker is moving, so the beaker add-on network is making some broadcast domain dynamically. Also using the pseudonym for the privacy issue, so changing IP address, right? So GN address is changes, also IPv6 address should be changed, okay? The last one is ISO, ITS. So specify standard support following global reachability of ITS stations such as a vehicle, and also continuous internet connectivity for ITS station, and also handover. Also the standard defined following support the basic IPv6 data forwarding, also the interface between IPv6 and the lower layer, MAC layer, such as a LAN or wireless LAN. And also IP address auto-configuration for static node or mobile node. And also the mobility management, such as mobile IP, and also security are considered. The next step, I believe this document surveyed the last 10 years vehicular networking in academia and standards. So I think this is good for the general problem area for IPWave working group. So I would like to ask the adoption of this draft for general problem for the ITS. Also, I augment, consider the inclusion of industry activities. Now there's many the vendors, such as automobiles working for self-driving, the cars, right? So we include that activity, okay? And also we clarify what is the specific general areas for V2X IPWave. So I'm welcome to your comment and your questions. Okay, Alex, go ahead.
So for clarification, there is a working group item in the charter that is called ITS General Problem Area.
Right. Yes. Yes.
And it is for that item that you propose this draft?
Right.
Okay. Is there another draft in this same or no? Okay.
Yeah. So I think the title is probably we can change, but I basically this draft covers the general areas for the vehicular networking, so IP based.
Okay. Yeah. So I support if there is a adoption request, then I.
Okay. Thank you, Alex. Yeah.
So I have a couple of questions. One is in the charter there is also mention about the use cases for that particular document, and as far as I check, there are no use cases covered in your document yet, right?
So I think we have the problem statement document, right? So I believe problem statement document can combine the use cases.
Okay, I mean, as it's written now in the charter, is more the use cases are more in this document, but that's something that we can figure out. The second question is more for the group. How many people have read this document? Please raise your hands.
For the recording, it looked like about 5.
So I think the personal opinion, document may be a good starting point for working group, but I would prefer to have some more reviews before we make the call. So please review the document, provide comments on the mailing list, and then once we have a couple of good reviews, we can do the call in the mailing list.
And we'll call on the list in a couple of weeks.
Okay. Thank you. Okay, go. Yeah.
Next. Mimon from China Mobile, and I see that in your assumption slide, the slide 3, and you say that the assumption of the vehicle network is that the IEEE 802.11p is considered as MAC protocol. I would like to know that such MAC protocol is only for IEEE 802.11p or some others are included. Because I see that in our charter, there are also another
Right, sure.
protocols.
Right. So yeah, I think at this time I include only the IEEE L2.11p. So definitely we can include the other, the MAC protocols. Yeah.
So you mean that in your survey, you will include other protocols?
Right. Yeah. Sure. Okay, let's move on. The next draft talking about the problem statement for Beaker to infrastructure networking. So the changes from the last Seoul meeting. So I augmented the security and the privacy section. So I addressed the authentication and the access control. Second one is the periodic change of MAC and the IP addresses So last meeting, two gentlemen presented these issues. So I tried to address this one, and also confidential data exchange. So objective of this draft to specify the problem statement for Beaker to infrastructure networking. So assumption is similar to a previous the survey paper. So this draft focus on networking issues, one-hop communications between RSU and the Beakers, and also the internetworking between the Beakers' internal network, it is called the mobile network, moving network. Also the RSU internal network, it is called the fixed network. So this figure describes the network configuration. So RSU is the router for the internet connectivity for the Beaker. So Beaker can access to the RSU to connect to some server, such as the traffic control center. Traffic control center mainly manage the Beakers. Also, it providing some other the cloud service. So the second one is remember the Beaker has an internal network, maybe the fixed wireless network or wireless network. So it has the inside the network. So it running some hosts such as adaptive cruise control or navigation system for the safety. Also, the RSU has also inside network such as other services for the driving, the guidance system or accident notification service. Okay, so this host and some server should communicate with each other. So this draft address how to support these kinds of communications. So the external link is the wireless, such as IETF11p over OCB mode or other MAC protocol. Okay. So just mention about the changes, update, security, and the privacy section. I mentioned the updated authentication and access control. Okay. So the Beaker ID PIN number can be used for the identify the Beaker. Also, the user certificate can be used for authentication. Secondly, the RSU can be used to deliver some authentication, some information. And also, TLS certificates can be used for the authentication and access control for secure communications between Beaker and the infrastructure node, RSU. The second one is the periodic change of the MAC and the IP addresses using pseudonym. So the important issue is this address update, the TCP connection should be maintained. Otherwise, it's not good for the services, right? And the confidential data exchange. So protect the data between the Beaker and the infrastructure. So first of all, we need to key exchange. We can use the IKE for key management protocol. Also, we can encrypt and decrypt using the IPsec. Okay, maybe we can use the different protocol. So next step is we'll merge this draft talk about the Beaker to the infrastructure. The Alex is, and the Dipang and the Perkins, they propose the V2V. So we will merge two draft into one problem statement document. Okay, so draft name will be like this. Okay, and also I will update the terminology with other standards, the bodies. First of all, I will synchronize this working group draft, and also I consider ISO draft. Okay, so thank you for your attention. Please say your comments and questions. Okay, Bob.
Bob Moskowitz, editorial comment on both this draft and the prior one. Replace all references of 802.11p with 802.11 OCB.
Okay.
That's a minor point, but
Okay.
we have to be consistent. It's OCB.
OCB, okay, sure.
Yeah.
Okay, thank you. Yeah.
Dapeng Liu from Alibaba Group. So I have a comment that I think the only working group standard that we currently have is the OCB working group draft, right? So if this document after merging with that one is targeted to the working group item, I think it should align with the problem to that of OCB draft, because it seems that this document and the other one is talking about V2V, V2X, but it's not quite related to current OCB working group documents.
So I think the current OCB case, just the communication, the external communication, not considering this kind of inside the nose communication. So there are a lot of the issues, how to exchange the prefix and the service discovery, DNS naming, handover. So this draft address many issues, so we can work on that. Okay, go ahead. Yeah.
Tom Herbert, can you go back to the second last slide, please?
Okay, second last slide. This one? Or previous, this one?
The one where you were talking about the address modification, and there was a statement to the effect.
This one, right?
So in the level of the network layer or transport layer, so I'm wondering if we can figure out a way to eliminate this being a transport layer issue. If we can just confine this to the network layer and just assume that transport layer can be whatever. What I'm worried about here is this might imply that we have to change a transport layer in order to support this. It'd be nice to have a layering to avoid that.
Okay. So the audience, other questions or comment? Okay, go ahead. Yeah.
Limon Chi from China Mobile, and I would like to know that for your authentication, you use the vehicle identity number, and I want to know who will make such authentication for the vehicle, and who can see the VIN.
Oh, VLAN? Say that again. What is
about the authentication?
Authentication. Okay, the last one.
Yeah. No, just another.
This one. Okay.
Yeah, the vehicle identification number, and you see that you want to use this VIN to make the authentication, and I want to know who will make such authentication and who can see such number.
Okay, so
which entity?
So I think we can have some authentication server. Okay, so RCU may have authentication server. Also, the beaker can have some certificate. So the VIN will be some identifier for that. So we can using that kind of a structure, we can authenticate. Yeah.
So my question is that if we use the vehicle identification number as for authentication, and you know that we may track such a vehicle because that we know its number, and its number is not changed periodically.
Right. So, but the VIN is a kind of some home address in the mobile IP point of view. So we can changing, so using a pseudonym number. So however, the BIN is, I think, is required. Okay, so somehow we have to carefully use pseudonym to disclose the security privacy issue. Okay, okay, thank you.
Bob Moskowitz. In fact, there are national regulations limiting the use of VINs in certain cases, so it's best to scratch this completely. Pretty much only the OEMs can use the VINs for authenticating back to their systems because of their need to deal with their vehicles in the field. But so scratch VIN completely from any discussions here. I would think would be the best thing to do.
Okay, thank you. Okay, Alex, yeah, go ahead.
Excuse me, Bob, if we scratch that, then what should we use instead? Okay, should we use username or MAC address or what?
1609.2 certificates, which are attempting to do anonymity. It's a problem, but I think our chair is rolling his eye on that.
No, I was noting the inconsistency in your advice. Earlier you said don't use those certificates because they change all the time, and now you're saying use them.
Well, you got 20 of them to use each month according to current model, and which one do you use? And there's whatever there is, there's some of them. I don't know too much on this, but I do know that there are limitations regulating the use of VIN, and don't step into that quagmire. And to comment, I mean, the only other thing we have is either like who's driving the vehicle, which has got its privacy issues, or the 1,000 whatever number of 1609.2 certificates active in the vehicle. Actually, the active in the vehicle is typically some. Yeah.
That won't stay constant. That's what they're looking for, though.
Yeah, yeah. There isn't.
Okay, that's a good point. Okay, so Michelle?
Yeah, what you can think is to use the VIN to retrieve the certificates, and then you have your certificates and you change them. Also, I think, unless I'm wrong, in the European e-call system, you are transmitting the VIN. When you have a crash and you are transmitting some data to the calling center, you are transmitting the VIN of the vehicle. So it can be transmitted in some countries. Again, it is country dependent, but it's not completely. It's not something that is completely hidden in your car and that does not get out of your car.
Is that the e-car specification you're talking about? Yeah, thank you.
And that's exactly why we should stay out of the quagmire. And in terms of that, and if you want something, it's the only consistent thing seems to be the 1609.2 certificate for authentication. But again, Russ shakes his head because actually he was there when they're first talking about that. So yes, I don't know. I'll think about it. I'll talk to some people. Try to shake a couple trees.
Okay, thank you. So if you have more questions, please send us by email. Okay.
Ask your questions.
Yeah, again, how many people have read this draft? Okay, so
Even fewer.
5, yeah. So again, I would recommend to get some reviews on the mailing list before we make the adoption call. Thanks.
Okay, thank you.
So we are done. Thanks. The other blue sheets, where's
the other blue sheet? Thank you.
Have a safe trip home.